So yeah, first of all, thanks very much to Nathan and to Rich for inviting me. It's great to be here, and it's great to see so many people turning out and wanting to learn about blockchain. I think this is one of those strange situations where a couple of years ago you wouldn't have been able to get anybody to even understand what the word blockchain meant, and now it's a thing that everyone's kind of really curious about. So one of the things that I kind of want to talk about is what blockchains are for. Because we kind of have a good idea now of technologies like the web. We kind of know what you can do with the web, what's it good for, what's it not so good for. We can do social networking, and we can do shopping sites. We can do marketplaces. We can do a whole bunch of things on the web that we kind of had to figure out with the kind of the best uses of that technology. And for blockchains right now, we've kind of got Bitcoin. And Bitcoin works, and everybody's kind of happy that Bitcoin is, on a technical level that it works, and from an adoption point of view, plenty of people are using it. And we've got maybe Ethereum is gaining adoption as well. But the kind of big picture sense of like, well, what is this thing actually really for, is the thing that I want to talk about. And the phrase that we use for this is the Internet of Agreements. And this is a shameless rip-off of the Internet of Things. But it's basically intended to convey the idea that what a blockchain gives you is the ability to reach agreement with other people around the world. You come to a consensus about a set of facts, and that's what's kind of unique and interesting about the blockchain as distinct from, say, the web. So a quick summary, and I'm not going to go into technical detail on any of this, but for people who are wanting to learn about the blockchain and maybe haven't encountered it before, a blockchain is a globally distributed database, which means that there are many different copies of the blockchain. And this applies to Bitcoin, it applies to Ethereum, it applies to all of the other blockchains, that has immutable history, which means that once something happens, once a record goes onto the blockchain, it stays there. And we don't change the blockchain by taking something out and replacing it with something else like we do in some traditional databases. We change the blockchain by adding something new to say, this thing that used to be 5 is now 12. This thing that used to be my old address is now my new address. And the history of the fact that my address used to be whatever it used to be, or that the number that's now 12 used to be 5, stays there. So we've got auditability. We can see the complete history of everything that has happened since the blockchain began. It has digital signatures built in, and this is the key thing that enables Bitcoin to work, for instance, that if I want to transfer my Bitcoin to you, I need to sign that using my digital signature that only I have. So this gives you some basic, and this is by no means a full identity system, but it gives you a basic sense that when we add things to the blockchain, when we create transactions, we're doing that as somebody. We're doing that as a thing that has a signature. So every record, every update that goes onto the blockchain goes on with a signature there to identify that we can tell that 5 different updates were made by the same person, or at least made by someone with access to the same key. The blockchain gives us a fair solution to consensus problems. So if we want to get a bunch of people around the world to agree on what order something happened in, who was first to do something, when all of those computers are kind of distributed around the world and there's no single computer that's in control of the network, that's actually kind of hard to do. I don't know how many of you are familiar with high-frequency trading. So this is the situation where close to the stock exchanges in New York and in London, people will buy up buildings and buy up office space right next to where the exchange is, so that they can run a cable directly to the exchange, so that they can get their information in quickest. And this is because this is a centralized system. There is a physical center. You can point to it and you can say, this is where the stock exchange is. And people who can get their computers closest to the stock exchange can get their data in and out faster than everybody else can. And this gives them an advantage. The blockchain solves this problem by not having a center at all. There is no center. And generally speaking, the way that blockchains decide the order that things happened in, or who gets to know what happened first, is that for every given block of transactions, and Bitcoin and Ethereum do blocks over different times. Bitcoin does one block every 10 minutes. Ethereum does one every kind of few seconds. For every given block, a different computer on the network will be randomly selected to be the one that decides the order of the transactions in that block. So there's, if you've heard of mining, this is basically the process of doing a whole bunch of computations to see kind of who generates the magic number first. Whoever generates the magic number first, they get to decide the order of the things in the block. And as a result, there's no advantage to being geographically located in any particular place. So it gives that global network the property of being fair in terms of coming to a consensus about what the facts are. And it also has some notion of programmability. Bitcoin has fairly limited programmability. Ethereum takes this further with smart contracts, and there are other platforms that come along with further smart contract technology. And what that means is not only can we write new data to the blockchain, we can also upload our own small programs to the blockchain, which then, when they receive some data, they will do some computation that we told them to do, and then they will produce a result which will write some new data to the blockchain. So this kind of package of things that are kind of bundled together give you a bunch of things that you can't do with the web, you can't do with traditional databases, you can't do kind of really any other way. So you've got full history for auditability, digital signatures so that we can tell that the updates are being made by the same people. We've got a consensus solution, which means that the whole system can operate without needing to have a physical center. And then we have the ability for people to create their own programs that then kind of live on the blockchain and respond to other people's transactions. Is everybody kind of basically okay with that as a summary of blockchain? Are there any questions or anything that anyone would like me to clarify? Yeah.
I have a question with regards to the digital signatures. Because if you talk about distributed database, you're looking at the speed of the computer to process a particular transaction or to understand and agree with a particular transaction. Digital signature implies that you have human involvement in this, or am I missing the point?
So when you make a transaction, so if you make a Bitcoin transaction, you have to sign that with your digital signature. So the transaction originates with a person doing something.
How does that work with regards to when you say doing away with a locality in close proximity to a trading firm? How does that work where you're having like I don't know 100,000 trades going on within, let's say, a 5-minute period, and a digital signature surely has, if there's human intervention, it can't happen.
Well, so the dirty secret of the current generation of blockchains is that the rate of transactions is very, very low. There are not very many transactions actually going through the system because when you add your transaction, it needs to be kind of federated out to a whole bunch of different computers across the network. And this is really slow. So what the current generation of blockchains does is trade off speed for security. So we make sure that all of the computers have got a chance to see your transaction, and then we randomly select one of them to be the kind of decider on the transaction ordering.
So it's almost like the settlement things where the digital signature will come in, so the computers actually have to agree
I mean, you could operate the whole system. You could operate the whole system yourself by having people email transactions to you that are digitally signed. The digital signature just says, I am authorized to make a transaction with respect to this Bitcoin account or this Ethereum account. So it's just there to say, you know, on a previous transaction your account was created when someone sent you some Bitcoin, and that account is linked to your digital signature, so that what the network then knows when another transaction from that digital signature is received that wants to transfer that Bitcoin to someone else, that it definitely came from the right person. Okay. Any other questions before we move on? Okay, cool. So to try and put this in a little bit of context, I'd like to talk about the 3 great ages of the internet. And you start sort of 1973, 74 with the first thing that could reasonably be called an internet, which is basically a bunch of universities in the US connecting their computers up to each other. And I think it started out with like 4 or 5 or 6 universities. And this was the internet of ideas, and this runs for about 20 years. And it's really just about information sharing. It's scientists, it's academics, it's researchers, it's some military people, and they're keen to be able to share information with each other, but they don't want to do business, they don't want to trade, they don't want to advertise anything, there's no commercial usage, it's just purely a scientific and academic process. And they build the things that people with those kinds of needs will want. So they build email, and they build FTP so we can send files around, they build news groups so that people can talk to each other. And pretty much the last thing they do, as it's the final act of the scientists for the internet, is they give us the World Wide Web. And in 1991 at the CERN Research Institute, Tim Berners-Lee invents HTTP, and we get the web. And pretty quickly, the web becomes so popular that a whole bunch of other people decide that the internet's pretty cool and they'd like to start using it. And at this point, the scientists lose control of the internet. And when the normal people show up, normal people want to do normal people things, like shopping. So the next stage of technology transformation on the web, which kind of runs from the mid-90s up until basically now, is all about figuring out how we can do shopping on the internet. So we do secure sockets layer, HTTPS, the PCI standards for credit card security, and it's really all about how can we let people type in their credit card number into a web page so that they can buy something. And we figured that out by the mid-90s. And then we proceed to basically take everything that we used to do by going into physical stores or by using catalogs and phoning people up, and we put that all on the internet. So you get Amazon, I pay you and you send me something, or we get eBay where I pay you and then you pay someone else and then they send me something, or Netflix where I pay you every month and you continue to give me access to something, or you get kind of Google and Facebook, which is really just advertising to people who want to do the first three things. And that's pretty much all business anybody's done on the internet in the last 20 years. This gives us like 3 of the world's 5 largest companies by market cap. It's absolutely huge, but it's basically just credit cards. And this works because it's a good fit for the web. The web is a request-response protocol. HTTP is a request-response protocol. So I send a request, I type in a URL, I send in a request to a server, and it gives me back a page. And maybe I send some data along with the request as well, like if I'm doing a Google search. And this is a really good fit for payment, because payment is, I send you some payment details, and you send me a receipt back to say that you've received my payment. So it all works really, really neatly. The thing that we get from blockchains is the ability to do a whole bunch of different kind of economic activity that the web isn't very good at. Because if you go, one of my old possessions is a book about the web from kind of like 2001 or so, and it's like, tells you about all of these amazing websites that there are and all of this kind of stuff. And you go through and you type in the URLs, and none of them work. And that wasn't that long ago. I mean, I remember that pretty well. For a bunch of other people, I'm sure that's 15 years is not that long of a time. So with blockchains, they kind of don't have that property. Once something's been put on a blockchain, it stays there. We talked before about the immutable history of the blockchain. So this makes it really suitable for, let's say you were doing something like a loan, where you expect that loan to be paid back over 5 years. You wouldn't want to think that the URL for your loan has kind of disappeared and then you don't know where to send your payments anymore, or you can't, if you've lent the money to someone else and they don't need to pay you anymore because the URL stopped working. So with the blockchain, we can put a record on there saying that I have borrowed £10,000 from you and I promise to repay you in this number of installments over this period of time, and we have a smart contract where I send the money every month, and if I fail to send the money, the smart contract will add penalties on and all of this kind of stuff. And this is a really neat fit for how blockchains work, and it's a terrible fit for how the web works. So what we can do with the blockchain that we couldn't do before is model and structure long-running agreements that run for potentially an unbounded length of time, because nothing ever goes missing from the blockchain once it's there, or multi-party agreements. Remember, everyone's got their digital signatures, so we can deal quite neatly with the idea that there are multiple people who are all signing things and getting involved in those smart contracts. And they can also be conditional, because the smart contracts contain code, so they can have if statements, they can have data, they can have all kinds of things that they might depend upon when they're deciding whether or not to add a penalty onto my failure to make a loan repayment, for instance. So the kind of possibilities that we get now is first-class digital representations of agreements between multiple parties. And this is where you get the kind of idea of decentralized autonomous organizations coming from. where you get people building new financial instruments on blockchains, and ultimately where we might get people structuring work contracts, music contracts, energy contracts, supply chains, all of these different things, because we now have a technology that is kind of shaped in the same way that the web is kind of shaped the same way that a payment is shaped. The blockchain is kind of shaped the same way a contractual agreement is shaped. So we've got a few trade-offs when we introduce this kind of new capability to the blockchain. Bitcoin, for instance, works really, really well because it keeps everything very simple. Bitcoin, at its heart, is just a ledger of how many Bitcoins there are and who owns them. And then it has some really, really simple rules for moving those Bitcoins around so that I can't send the same Bitcoin to two different people. And that's pretty much it. And by keeping it really, really simple, Bitcoin has been extremely reliable. No one has ever hacked Bitcoin. People have hacked Bitcoin exchanges, people have hacked Bitcoin wallets, but no one has ever actually hacked the core Bitcoin protocol because it's fundamentally well engineered and does one pretty simple job. But if you think of what it represents, if you just kind of imagine this giant kind of ledger that sits on the internet, it really only has one kind of thing in it, which is Bitcoins. What Ethereum allows us to do is put other kinds of data on the blockchain. So we can invent new kinds of things that will be stored on the blockchain, and we can write new kinds of rules about how we move them around. So rather than relying on the Bitcoin core protocol, we can write our own rules in smart contracts, which says that I can send you my, I can invent a new kind of digital currency, and I can invent a new kind of token. But I can't send it to anybody on if they already have more money than I do, or I can only send things on a Tuesday. Arbitrary rules. We can write any kind of rules that we want, but with great power comes great responsibility, and it turns out that kind of smart contracts are pretty hard to write. So as we get this new sort of flexibility, we get the ability to screw up in some pretty big ways, and plenty of people have done that. So when you hear about people being hacked on Ethereum, it generally is because somebody wrote a smart contract that had a bug, a bunch of other people sent a bunch of money to that smart contract, it's sitting there with X million dollars kind of held in a vault under the management of the smart contract, and then someone else comes along, sends the smart contract a transaction that triggers a bug, and pretty quickly the money goes missing. So the kind of engineering that you need to do for smart contracts is kind of closer to programming a nuclear power plant than it is to programming a website. It's dangerous. If you get it wrong, you will lose money. Because fundamentally, smart contracts are hard. Most software has bugs. Websites have bugs. Mobile phone apps have bugs. If you look on any given day at the App Store or the Google Play Store or whatever it is you have, you'll see 25 updates, and you look into the description of what the updates are for, and it'll say bug fixes. It often won't say what the bugs are, but it'll say bug fixes. And what that means is not really so much that someone screwed up. I mean, as a software developer, and I've worked in software all my career, there's been plenty of times when my software doesn't work. But normally it doesn't work because someone runs it on a computer that I couldn't have anticipated them running it on. They'll run it on some version of a web browser that I didn't test, or they'll be on some version of an operating system that I didn't test with a screen resolution and a graphics card and a network driver. Maybe they'll be on a really bad network connection. Maybe they'll be running some kind of weird ad blocker. There's all kinds of different things that could cause that to go wrong that are fundamentally beyond my control as a developer. So as a result, nobody cares. We say move fast and break things, which was Facebook's famous phrase. What you're really measuring is not how many bugs did we have, but how long did it take us to fix the bug after we found out about it. And then we just push out hundreds of new features, hundreds of new bugs, and hundreds of new bug fixes every week. And this is normal. Everybody thinks that this is completely okay. But if you did that with smart contracts, you'd be totally screwed, because you introduce that quantity of bugs into smart contracts, people will be stealing money right off the fact that you've got those bugs there. A single piece of code, a single function could be responsible for managing millions, tens of millions of pounds worth of actual value held in cryptocurrencies. Fortunately, if we go back to our earlier consideration of what a blockchain is, it's a globally distributed database running across thousands of computers. When we execute a smart contract, we don't just execute it once on a randomly selected computer, we execute it on all of the computers that are taking part in the mining. And this means that we don't get caught out by the fact that some random person somewhere is running some completely weird hardware. If they get a result that doesn't agree with the general consensus across the network, their version is thrown away. So we get an agreement across the network that this computation had these inputs and it produced this output, and everybody agrees that is the canonical output for that function. And it can only look at the previous state of the blockchain and the stuff that's currently come in this transaction in order to determine what to do. It can't go off over the network and read new information. It can't get input from the keyboard. It can't load files from the disk. It can't generate random numbers. It can't do any of these things. It has to be deterministic. It has to be based just on the previous state of the blockchain and the current transaction. So that means if a smart contract fails, we know that it was definitely a bug in the smart contract. And I kind of have a suspicion that once the culture catches up with this, once the engineering culture catches up with this, we're going to start to see a very different attitude towards smart contract programming to what we see with web development. We might actually start to see professional liability for programmers, for instance. You might be sued if your smart contract goes wrong and loses people's money, because we know it was definitely your bug, and we know exactly how much money was lost as a result. So perhaps professional indemnity insurance for programmers, all kinds of really weird and bizarre things could actually come back into fashion that we thought we'd kind of avoided doing 50 years ago. Actually, on blockchains, that kind of stuff does actually make sense. So I want to look at one kind of slightly more futuristic application of blockchain. If we think ahead a few years as to how blockchains might start to invade the real world. Right now, we've got a bunch of stuff going on out there in the virtual space. Lots of people making money, losing money, hacking people, and so on and so forth for Bitcoin and Ether and tokens. But if you switched it all off, would anybody really notice outside of the blockchain community? Probably not. It hasn't become kind of fundamental global infrastructure. There are a few people who depend on it, but most of the people in this room, aside from the fact that we might lose some money, wouldn't really care. Whereas if you switch the web off, people would notice pretty damn quickly. So if blockchains are going to become important, then they are going to have to become the backbone for our mortgages, our loans, our insurance. You're going to have to be able to buy a house on the blockchain. You're going to have to be able to buy a pair of shoes on the blockchain. You're going to have to be able to make an agreement that the proceeds of sale of your new album are going to be paid out to these following people who backed you on a crowdfunding platform. You're going to need to be able to credibly commit to doing all kinds of stuff in the real world, so that instead of having a big ledger of all the Bitcoins or a big ledger of all of the kind of weird Ethereum tokens, we have a big ledger of all the physical stuff. The buildings, the cars, the intellectual property products, all of these kinds of things. So what we need is to think in terms of contracts. We think in terms of what we're putting on the blockchain is actually statements, commitments between multiple parties to do things with each other at some point in the future. The smart contract can handle a whole bunch of the kind of shuffling the money around. It can handle shuffling the data around. And this, as we've kind of discussed, requires a very high standard of engineering. The final piece of the picture, and the piece that's going to be the hardest to put into place, is actually getting this stuff accepted in a court of law. If I send you some Bitcoin, and you told me you were going to send me a pair of shoes, and you don't send me the pair of shoes, what do? If I turn up in court and say, this guy said he was going to send me some shoes, and I sent him some Bitcoin, the judge is probably going to be like, bit what? And I'm going to have to call an expert witness who's going to have to get up and do a version of the talk that I've just done, and that person's going to charge like £3,000 an hour, and it's going to be terrible. No one's going to want to do that kind of thing. And it gets even worse if the person who promised they were going to send me some shoes lives in another country on the other side of the world. So we think that we found a solution for this, and by we I mean Mattereum, which is the company that I'm a co-founder of. And our solution to this is to use the existing legal systems mechanisms for dispute resolution in the form of arbitration. So what we do is we take smart contracts and legal contracts and combine them together. So the kind of performance details, the kind of, did you send the payment? Did the payment, did you send the payment when you were supposed to? What are the charges that have been paid? All of that kind of stuff gets fully modeled inside the smart contract. But the kind of legally enforceable promise that you're actually going to do something in the real world gets modeled in a legal contract. So we sign an agreement with each other about what it is that we're going to do, and if I don't do my part of the deal, you can take me to court, or rather you can take me to arbitration. And it turns out that arbitration is this totally bizarre thing that a whole bunch of commercial law runs on that actually very few people have heard of. Under the terms of the 1958 New York Convention on Foreign Arbitration Awards, if two people sign a contract and they say, in the event of a dispute regarding this contract, this dispute will be handled by arbitration at the following arbitration association, then they can't go to court to handle this. They have to go to arbitration, and they have to accept the decision of the arbitrator. And this applies in 150, 160 jurisdictions around the world. So you can freely enter into agreements with people from Brazil, or America, or France, or Vietnam, and in the event that either of you disagree, you can have an arbitrator who actually understands the technology, who understands how the whole thing works, has access to the blockchain, who has access to the smart contracts, who can see everything. And this person can make the decision for you, as long as you agreed in the contract that this is what's going to happen. And this turns out to be how we handle maritime arbitration, how we handle maritime disputes already. You're shipping rice from Vietnam to Brazil, the ship sinks off the coast of Somalia, but the insurance was in Switzerland, and the ship was registered in Greece, but the ship was actually owned in England, and the parties are actually based in, Russia and Argentina. Rather than trying to hash that out in the national court systems of all of those countries involved, they all agree to use binding arbitration, typically in London, because London just has a history of doing all of this kind of stuff for maritime. And that's a way of getting a consistent result that everybody understands ahead of time is going to be the result. We know, everybody understands English law, they understand how the London arbitration system works, and this smooths out a whole bunch of problems that would occur in maritime disputes. So in the same sense that things being shipped over the sea kind of have that property, deals being done over the internet have the same property, that people making the deals could be based in all kinds of different places. If it's a multi-party agreement, there could be all kinds of different jurisdictions involved. So what we've built is a system to allow people to make those agreements that have binding arbitration built in. We have a group of arbitrators based in London who are familiar with the technology and who are able to hear the cases. And we actually have legally enforceable blockchain contracts running now on Ethereum. This is our contribution. This is what we think is going to be necessary to enable people to build real-world systems that run on the blockchain. We think that this is the right way to handle it, and a way of sidestepping a whole bunch of legal issues and kind of jump 10 years forward in terms of how long it would take us for the courts to kind of figure out how the blockchain should be handled. And we've started to see a whole bunch of other companies come forward now who want to build, as I mentioned, supply chain contracts, energy contracts, music contracts, all kinds of different things, where they can roll out much faster because they know that they've got this consistent legal kind of framework that they can build on top of. And I think if I wanted to take the kind of the British angle on this, it just so happens that this is running on English law and the arbitration is based in the UK. But there's an interesting facet of the Internet of Agreements on blockchains that we think is different from the kind of last kind of 20 years of the web and mobile, where the web and mobile have been kind of dominated by companies from the US, because the US is a kind of 300 million people single jurisdiction with a single legal system. And people build things in California, and if it works in California, they can roll it out to those other 300 million people pretty much immediately. They don't have any kind of jurisdictional issues or anything like that. But in this country, we have a bunch of expertise about how to do legal agreements. We have a bunch of expertise about how to do finance. We have a bunch of expertise about how to do trade. And if we said that the single legal system that this new internet is going to run on is one that we're super familiar with, and if you can build a business that works in Brighton or in London or in Manchester or in Newcastle or in Edinburgh or in Cardiff or wherever, and it will run on the same legal principles that the rest of the world is able to run on, then you can roll that business out much faster than you used to. And that, I think, is the the potential for British companies, for UK companies, to be able to make something work at home and then immediately have it work around the rest of the world in a way that the American companies have been getting an advantage from for the last 20 years because their home jurisdiction is very, very large. By creating a kind of virtual jurisdiction of the internet, we give that advantage to basically everyone in the world. In the same way that the blockchain decentralizes business and says there is no one central place where you need to be in that central place to get the best access, this system says there is no central place. You're not any better off being in Silicon Valley than you would be anywhere else. It's an open playing field and anyone can play. So that basically is my vision of what the blockchain is, what it's for, where it's going to go, some of the engineering that we need to do to get there, and a lot of it is actually more legal engineering than it is technical. And I'd be more than happy to talk to anybody who'd like to know more about those kinds of things. And with that, I'd like to hand over.